Okay, this video is the fifth video in the series on molecular substances, specifically the intermolecular forces between molecules. And in this video, what I'm going to focus on is the intermolecular force, which is called the dipole. The dipole force. All right, now, the dipole force, all right, this is a force that exists in molecules that have structural dipoles. Structural dipoles. Now, what does this mean? What this means is that these are going to be molecules that have opposite charges on opposite ends of the molecule. So again, structure is really going to play an important part in determining whether or not a molecule is a dipole or not, or for example, whether it's a hydrogen bonder. Because remember, an H bonder is a specialized dipole. The dipole is a molecule that is not a hydrogen bonder. However, it has opposite ends on opposite ends of the molecule. Now, to illustrate this, the first molecule that we're going to look at is going to be this one. This is called acetonitrile. But for our purposes, the name doesn't actually matter. What matters is that we take a look at this molecule and we can determine that it's a dipole. Now, how do we make that distinction? The first thing is that we need to have a structure that puts that creates a situation where we have different ends of the molecule. So I'm going to expand the formula on this so that we can see the Lewis formula. So we can see the arrangement of all the atoms in the molecule. And when you look at this, you can see clearly that there are two ends to the molecule. And I use this idea of top and bottom. It's completely arbitrary. Actually, I should have moved that over one. All right, sorry. Let me just fix that really quick. So this line that I'm drawing should have been moved over one, so it should be here. Right? So we can distinguish two ends to this molecule, and arbitrarily I'm going to say this is the top and this is the bottom. You could name it something else if you want. Just need to understand that we've got two ends. All right, and then here's the deal. If we look at the nitrogen, it's in a triple bond with this carbon. All right, and the nitrogen is more electronegative than the carbon. And what that means is that the electron density that's in these bonds is going to be shared unequally. It's going to be shifted towards the nitrogen, All right, and I'll put an arrow in here to indicate that. Well, let me get a different color. We'll try this. All right. So the electron density is shifted this way. It's shifted towards the nitrogen. So the net result is that you're going to have a slight partial negative charge on the nitrogen. You're going to have a partial positive charge on the carbons, on this carbon. That's going to be translated out over here. All right, and the bottom line is we have opposite ends. We have opposite charges on opposite ends of the molecule. So you can imagine another molecule not too far away that's going to be adjacent to this, that's going to line up so that its little partial positive charges are in proximity to the partial negative charge on the adjacent molecule. So our intermolecular bond is going to be in here. All right, another example of a classic dipole is this molecule. Okay, this is nail polish remover, otherwise known as acetone. All right, and again, when we look at the structural aspects of this thing, again, we can draw a line, and that line's going to be like through here. You know, there's definitely a top and a bottom to this thing. All right, and again, we have an oxygen which is bonded to this carbon, and they differ substantially in electronegativity. So the electron density is not going to be shared equally. It's going to be withdrawn towards the oxygen. So we're going to have a partial negative charge on the oxygen. We're going to have partial positive charges on this end of the molecule. So literally, we can have another one of these molecules in close proximity, all right, that's going to get lined up on with the adjacent molecule in regard to the charges. So we're going to have a slight negative here, slight positives here, partial charges, all right, and this negative is going to be lined up with the adjacent molecule. All right, and this being the IF, or the intermolecular bond. Okay, so here these represent two examples of what I would consider classic dipoles: acetonitrile and acetone, or nail polish remover.